Well, while we're on the topic of homework, any questions?
Um,
Anything you want to go over?
I don't understand nothing.
I
Yeah,
got you.
Professor, I certainly help on the topic that was still going.
Well, we didn't finish that, so that's fair. Yeah, that's fair. Yeah.
So,
All right, so let's look back at where we left off then.
you got here early, Professor.
Mm-hmm. Mm-hmm. So just a quick recap. This where we left off. Hold on. I done clicked the wrong thing. 1 second. Yeah, did y'all see that warning message yesterday? Something happened. Yes, I can't explain it, but something happened yesterday where the internet was down. But it wasn't like, yeah, it wasn't like a BCC thing. It was like a worldwide big thing. Mhm.
Wait, at what time? At what time?
I want to say it was in the morning time. It was random, you know. So, me personally, I was Google searching something, and then I got this error message. So, but I'm thinking that's my fault, you know. But when I came to campus, I saw somebody else's computer, and they had the same error message. I'm like, hold up. Yeah. All right. So this was the last example that we did, right? We want to find the area between z equals 1 1.00, excuse me, and z equals 2.70, right? So we said that we have a distribution like so, right? Where in the middle is our mean, which is at 0. Then we said 1 was something like over here, and then 2.7 is something like over here, right? Hmm. Yeah. And the area that I'm looking for is this part in between right here. This what I'm looking for. This what I want. Right? That's what I want. That area right in between. Right? So, as I was saying with the pictures, right? What can we do? You remember that our table only gives us areas to the left for less than, right? So I can use that fact to help me find this answer here. So I can take, I'm just gonna do a little baby table right here, right? Let's say that this is 2.70, right? I can take this area here to the left, all of that, right? And I can subtract it from this other area that's right here. Let's say that that's the 1.00 to the left. Which one? The 1.00? That's what the table is going to give me. Yeah. Yeah. Let me using the formula, right? Essentially what I'm asking you is I'm asking you what's the probability, right, between 1.00 less than z less than 2.70. This is what I'm asking you. And then I'm telling you to take the area to the left of the 2.70. So that's the probability of z less than 70. Mm-hmm. And I'm going to subtract that from the dollar, right? The probability of z less than the 1.00. Mm-hmm. And then that's it, right? After that, it's just a table, right? We remember how to look these up, or you guys want to refresh?
Can you show?
All right, I got you. No problem. I got you. I feel like I thought somebody might have left some here, but yeah, I had some formula sheets up here, if anything. Yeah. Excuse me. Sorry about that. Also, some in the desk here. You're welcome. There we go. You're welcome. I don't know whose that is, but yeah. So anyway, right? We're doing a normal distribution, so we have to use a normal distribution table, all right? You're fine. You're fine.
So what would a normal distribution?
So I'll show you. So when you're on your formula sheet, right? What you want to do is you want to turn to the page where the normal distribution is. So
The bio one, right?
not the other one. Bless you.
Oh, the area.
Bless you. This one that says area of a standard normal distribution, right? So I'm looking for positive 2.70, right? Positive 2.70. So the first table here is negative, right? These are negative z's. I want that positive z to the next one, right? So the next one, here goes my 2.7. See it right here?
2.7 is
Right?
0.953, right?
0.9965. Because remember, the hundredth place, right? The hundredth place is up top up here.
That's right. Are we in
Right?
the second part of table 3?
The second one, yeah, with the positive numbers. Yeah.
So the first part is.
Both positive. Both positive, yeah. Because I have a positive z. That's why. Right?
Okay, so it's 0.9965.
Right. So then now we're gonna write that in. Got you. So I'm on positive z. Like you see the positive z's right here? You go down to where 2.7, right? And then you go across to where the zero is up top. See the zeros at the top here? Yeah. Yeah. Right? So I'm gonna write that in right now.
I'm gonna wait till you write it in so I can read it correct.
I got you, no problem. So this is the 0.9965, right? And I'm gonna subtract that from the 1.0, right? Let's look up the 1.0. Mm-hmm. And what you got? Let me see.
Am I supposed to go down to 1 to 0.1?
No, so look, 1.0 is right here, right?
0.
And the zero up top, right? That's to tell you which column to look at. So what number did you get? That's it, right? So we're at 8413. Everybody got that?
Wait,
So, huh? Yeah.
that was the second part?
Yeah.
Either the silly.
I got you. Uh-huh.
Okay, what was the other part?
Yeah.
After the 2.7? It was 1.0?
It is.
So 0.8.
I'm sorry about that, guys. Yes, it will tell you that. Like Z is gonna tell you if it's positive or negative. And then thank you. And just remember that the table that we have here, looking at where that picture is, right? It's giving me areas to the left when it's less than. The table doesn't give me greater than. But we're gonna talk about that today though. All right?
I know when it comes to like, I don't remember right, so it's like that,
Mhm.
most people that's like positive, when it's like empty today.
When the Z value is on the right hand side more, it's positive. And when it's more on the left hand side, it's negative. Like that. Yeah. Mhm. Which one?
Is this the answer? Right there?
Yeah, that's it. Yeah. I'm gonna catch up with you right now. So 8413. Yep, that's it. That's all I was looking for.
Still trying to, yes.
Oh, my fault. Hold on one second. Uh-huh.
See, the setting seem to be 1.3, right?
Go ahead.
And would the O also be part of this?
Yeah. So the middle, that's 0.00. So look, you see where it says 0.0 at the top?
See that?
Yeah, so going straight down. Wait, hold on. 1 second. So going straight down these numbers, right? These are like the first two digits. So like 1.3, right? That's here. But there's another digit that comes after it, right? Let's say it was 5, right? So you'd find the 5 up top here. And then you look at where do they intersect that, right? So then this would be your answer right here.
Okay, so it would say. We said 1.3 and 5.
Right. So it'd be like 1.35, right? So you come down to 1.3, and then you come across to the 5 up top here and look at where they intersect that, which is right there. 0.9915. Gotcha. No problem.
I have one more question.
Mhm.
So one thing that I'm not understanding,
Mm-hmm.
this is the formula, right?
Mm-hmm.
And I don't understand what I'm supposed to do according to the lesser grade.
They're both gonna be less than, because I can only look up less than in the table, but you want to look up the big one and subtract it from the little one. No, I'm sorry, you want to look up the big one and the little one and
big one
subtract
first.
it. Yeah.
So I don't need to think much of that.
No,
So-
you're good. You're good.
Exactly.
Yeah. Nah, you're good.
That's why I end up getting things wrong.
You're good. All you need is what I write here. I wrote here. Right? So this was the 0 point, you said 8413, right? So after that, just a little bit of calculator subtraction, and that's it. Right? It's okay. 9965 0.8413. So this is the 1552. And that's it. So just so we're clear, right? That's the area under this curve right here. 0 point? Nah, you're good. You're good. 1.552. This is what we did yesterday, right? So that's the final answer for everything. That's it. Any questions on this though?
No, I'm getting it, Professor. Thank you. A couple more, right?
So I'll give y'all a minute to copy. Ken, give me 1 second. Ken. I want to talk to you about this. So this is good, right? Some good progress was made on this, all right? All of that is good. This is good, right? This is still wrong though. So we
Oh, you
gotta.
told me that was, you was like, you said that was good.
Nah, this is not.
Oh.
So we gotta fix
Oh,
that.
did you?
I didn't do that yet. I'm just waiting on a couple people to finish. Over here, all is good. I'm missing the range. That's not the range.
The range would be. No, the new range is right here.
Nah, that's not it. Remember, range is the biggest number minus the smallest number.
20.
Minus 10, that's it, right? But hold on, let me see something else. There's one more thing on the back. So the median wasn't right here. The standard deviation is not right.
The new stuff is right. I got like circled this for it to be new.
Got you. So I might be wrong about the standard deviation. But the CV for sure, this is not right. Yeah. So remember, that's the standard deviation divided by the mean times 100.
That's what I got wrong.
Yeah.
This is so
I
hard.
mean, it is 160,
One something.
was 167.29.
Yes.
Right.
And then what?
The standard deviation.
Do that.
That shit was so confusing for me.
Okay, wait. I'm just slow down for a second.
Yeah.
So you saying the mean divided, or the CV, right, would be.
Yeah, so let me see this one.
Oh.
So CV is right here. Right? So it's the standard deviation.
Oh, I mixed up with the mode.
Yeah,
Okay,
it's all.
I think like sitting mistakes like two.
It's all.
That's what we gotta do for this. It's crazy.
Yeah.
Just fix it up and give it back, and then I got you. Alright?
To you, because I studied that on a calculator, and that's the only reason why I was able to do that. You did it manually. You should pat yourself on the back.
Yeah, that's all you said, so I can just.
I got you. I'm thinking about next week, Wednesday, the latest.
Yeah.
Yeah, yeah.
Out of family.
Yeah, we have like another test on December, right?
In December, yeah.
Is that the final or is that the third?
Nah, that's a third test. Yeah.
And
We have a third test, a fourth test, and then the final. Like,
Oh.
yeah.
And the test is like 20% for. So let's say if we don't do well on the final. If we go with the other tests.
Remember, it's a weighted average, so it's not.
If
We're gonna be okay.
if we do good on these tests,
Mhm.
but don't do well in the final, we good?
Yeah, we good.
That's what I wanted to know. We got this.
It's a percentage of your grade. It's not your overall.
The other lady, what's that?
We should, I'm down for that. I just had like
That's good. She
a
got the.
family emergency, so I've been out of it, but I'm.
No, that's all. I'm always like this.
She got the group right there.
Wait, I think I talked to,
Yeah.
wait, no, I talked to the other lady about like
Can
the
you
whole
please
chat.
circle what's gonna be on test two that I'm about to take? Please, can you just circle this? Cause I know you said I'm gonna take it Tuesday, right? Yeah, so I just want you to just circle what I gotta look at, cause I'm so out of it, Professor. I wanna try my best to.
This stuff,
Okay.
not this in particular, but you know, with the scatter plot, that thing.
Okay, which I can do on the calculator, right?
General.
Thank you, Professor. It's been real, like my
This
CSV is real.
This stuff.
Okay.
I mean, this whole section, to be honest with you, that whole thing. Not that. This is what I'm doing right now.
And nothing from other pages?
No. We didn't get there yet.
This is for test two.
Yeah, that's it.
That's fine.
Yeah.
Professor, I'm ready to try my best.
We gonna get there. Got you, no worries.
Or just this for test two.
Look at my class announcement, and you'll see all the topics. Yeah, everything is there. I got you. Yeah. It's good. It's good. Hold on. Not the last announcement. It might be like 2 or 3 announcements before, but I list out all the topics that's on the test. Dude. Yeah. I got you. All right, so we good copying? Everybody's good?
Yes.
All right. So 1 second.
Oh, no. This? No, that. Oh, that's. Yeah.
All right, so here's our next question. A little bit different. We didn't get to talk about this. All right. So I want the area to the right of z equals 0.94, right? To the right of it. So a little bit different. So let me draw that out. Hold on. I got the wrong color. 1 second. That's good. I'm glad. Right. So you remember in the middle is 0, right? So 0.94, right, is positive, so it's going to be a little bit more to the right. So let's call this 0.94. Now, more specifically, right, I want this area right here. Same thing, but it's on the right. But the issue is that my table only gives me probabilities to the left, right? So how do I get the answer? So I'm gonna show y'all. So what I'm gonna do, the other side, I got you. The other side is the left side.
So the table to the left side.
Right. That's the issue. That's the issue. Yeah.
Well, we gotta be a trick in there.
Yeah. But it's all right though, because we have a workaround. So here's what we're gonna do, right? We're gonna take the whole distribution. So I'm talking about all of this.
The whole thing.
Yeah, the whole thing. So I'm gonna take the whole thing, right? Yeah. No, it's gonna be a decimal. Always a decimal. Always decimal, yeah. So I'm going to take the whole thing, right? And I'm going to subtract that, right? From the less than 0.94, right? So this area here. And then the answer that I'm going to get is going to be the final answer, right? So not too bad, right?
Not that bad, but.
Exactly. Or one, right? So then this just like to show you the formula, I'm asking you what is the probability of z greater than 0.94? That's the question, right? So what I'm gonna do is I'm gonna take the probability, right, of z. Actually, I'm gonna take the whole thing. Let me just call it one, right? Like one minus the probability of z less than the 0.94. Right? That's what I'm working it out to be, right? So this is gonna be one minus 0 point something. Nope. Uh-huh. The one is this part. That's the one, and then this is that. Yeah. So now I just gotta look up 0.94 in the table, right? Yeah, to the left. Mhm.
We would go to.
But that is positive, right?
It's positive, right? 0.94.
8159.
All right, let me check. So do. Say what you got again. I'm sorry. Say the number again. No, no, no. So it's 0.94, right? So 0.9 is right here. I'm sorry. There we go. Yeah, yeah. Why is this thing not highlighting? There we go. I'm sorry.
What page is?
8264. That's it. Right? Yeah. Yeah, yeah, yeah.
89 on
Yeah.
top.
So go to 0.9. Yeah.
Yeah.
So you go to 0.9 and then you find the four up top and you look at where they intersect that, right? So that's gonna give me the point, right? Mhm. Right? Everybody got that? Got it? Yeah. Look at the formula sheet and then look at where they intersect that. Then you can get that. Mhm. Mhm. You just
264 take away two.
no, like one minus 0. Yeah. 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 Yeah, so this is the table that says normal distribution, like standard area under the normal distribution, but this is the positive side. The positive side, right? In
Take away 0.8264.
the calculator. Yes.
Yeah, I figured.
Yeah.
Okay, let me know when you know.
It's like a dollar minus 82 cents, something like that.
You see why I
Mm.
love it.
Thank you. Thank you.
You make it so simple in your head.
Yeah, I try. So yeah.
But what's the final
So
answer?
let me switch back. 8264. Let me write that in real quick. All right. Let me catch up with y'all. 8264.
Polish farm.
That's fine. Yeah. So then this would be all right.
Right now.
I trust you.
Me too.
Wait, do we have? I'm writing it down. It being so.
You could write point. Yeah, I like to have the zero. 0.1736. Yeah.
But if you just wrote 0.1736, it's fine, right?
Yeah. Because I mean,
Okay.
how could I say this now? Like if I saw like 17 cents, right? Me personally looking at 17 cents, I would feel a lot richer than if I looked at 17 cents like this. you know? So like, yeah. Yeah.
Professor, where's that one coming from? What is that? That's coming from?
That's the whole distribution. This part, that's the whole distribution right here.
Oh, okay, the
Yeah.
whole thing.
Yeah,
Okay,
yeah,
got
yeah.
it.
So,
Mhm.
Professor, you said that the reason why we're using the whole distribution is because they're asking what's the area to the right of 0.94. Is that why? Why are we using the
Yes,
whole
that's part of the reason, right?
Okay.
The a more detailed reason is because of the symmetry of the normal distribution, right? When you cut it in the middle where the zero is, what happens on the right is the same that happens on the left. So it's because of the symmetry why I can use the whole distribution and just cut out the piece that I don't know and be left with the piece that I want to know.
But
Right.
instead of asking
When
for
it's
the
greater
right,
than, yeah,
when it's
Yeah.
greater, that's right.
yeah, I got you.
When it's asking to the right and I'm gonna put a sign, always use.
I got you.
When it's asking the area to the right,
Right?
which is greater than. But you said that it's gonna give us how to do the, how to get the answer, right? In the whole.
Like, what do you mean? Yeah, that's what right. That's exactly what they're gonna ask you. Yeah, yeah, yeah. And then you just look it up and just type it in, click submit, and that's it. Yeah. Yeah. But-
It looks so complicated.
Mhm.
So it's the mean and range.
Uh-huh.
Divided times the budget, right?
Say it again. The mean.
It's the.
Oh, for the test? You mean? So it's the no, the standard deviation divided by the mean. Yeah. It's on the formula sheet. Standard deviation divided by the mean. Yeah. Yeah.
Okay.
Yeah.
I mixed it up because instead of putting 14, I should be putting like 167.
Right.
Yeah, it's the probability.
All right, here's another question.
So it'll be
Try that out.
this.
So,
Go ahead, try it out.
So it'll be this divided by this, right? These two together.
Yeah, this divided by times 100. Yeah. That's it. Yeah.
Sorry.
no, you're fine.
Just so we're clear, this is all I'm asking you to do. All right.
So you want to find the area to the left of 1.1, of 1.15?
Right. That's greater than.
Oh.
Yeah.
To the right.
Mm-hmm.
Why didn't you tell it?
Try it out.
What do you mean you got a shade there? You have to write it on the graph. That's what you want to. I don't
Mhm.
even.
It is. It's the same problem. The same problem.
So again, if you want to find it to the left.
To the right.
Just-
The table can only give you to the left, but I want the answer to the right. I got you. All I'm asking you is the shaded part. I mean, the highlighted part. That's it. But in my opinion, drawing the graph and shading it in helps you find it. In my opinion, I don't know.
So when I shade, that's gotta be from the top.
To the right. Yeah. Is this right? Wait, hold on. Cause I have to remember I'm sitting different from you, right? This is your right, right? Yeah, I'm sorry. No, but I'm talking about like from me to you. So this is your right. This is your left. Yeah. It's been a while. Like when I was in elementary school, we did a little acting, and I remember it was opposite. Yeah, like stage left was different from left.
So
Probably.
you playing with
Yeah,
me.
that's it. Yeah, that's it.
Professor,
Yeah.
stop playing with me. I just did this, right?
Yeah, that's it. Yeah. That's it. Now you can knock out your homework.
That one.
Mhm.
the-
Hmm?
But it's.
No, the Z formula is if you have I give you an X. Like so say this was find a probability of X greater than 35. I'm just making something up, right? Then you change it into a Z and then do this. Draw the curve. The same way you saw me do it, right? Remember I drew a distribution and then I shaded it. That's it. Well, it's a little. Well, you got a pencil. You know, I got a pen, so it's a little harder for me to shade. So I just draw lines. Yeah, 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 yeah. That's it. I can see it. Yeah, yeah, that's it. Yeah. Mm-hmm. That's what I want. Oh, give me the answer. What's the answer? For the right side.
It's what we just did, last time.
Yeah. So like, look it up in the table. Give me the answer. Let me know when y'all get it, or if you give up, just let me know so we could go through it.
I want you to go through it so I can make sure I really did it.
I got you.
If you were to shade it to the right and then.
Right, that's what I want. Mhm.
We gotta do it exactly like the one we just did. Yeah, that's what I'm looking at.
Mhm.
But that would be the one. Then. Yeah. No, the one you need yours. I want to try. Okay, you got this, girl. That's right. You could do this one, right? Leave it to the right.
By the way, in tutoring, we got like this dope sharpener over there. Like if y'all got any like old school for real. Like it's new. It took us years to get it. So that's why like I'm advertising about it. Yeah. All right, while y'all working on this though, let's do a commercial break. So y'all know next week, Thursday, right? We don't have class. It is no Wednesday. Wednesday.
Oh. I have to say a Thanksgiving break, sorry. No,
So
we just get Wednesday and Thursday.
No, Thursday and Friday. Yeah, yeah, Thursday. So,
Wednesday?
yeah, yeah.
I have a Wednesday and then after.
Nah, we got class on that day. But listen, but listen though. In regards to that, right? All right, watch the recording. It's fine. But listen, so next week Thursday's Thanksgiving. That means that today and tomorrow is a Thanksgiving pantry. All right. Make sure y'all go. All right. Y'all could go y'all could go after class today or y'all could go tomorrow, whatever. Right? I got you. Huh?
Yeah.
Okay, go ahead. That's fine. All right, that's fine. Yeah, that's fine. Yeah. Mhm. Yeah. Yeah. It has to be Tuesday. Yeah. Tuesday. Yeah.
Responsibilities I have.
I got you. I got
Day
you.
before Thanksgiving.
I got you. I got you. I got you. All right. So anyway, are we good? You want to go over this? No?
Yeah.
All right. So look, I'm looking for. Hold on. Let me get my pen. That always happens to me. I forget to take my pen out. All right. So I want the probability of Z greater than or equal to 1.15. Right? Okay. Now remember, I was telling you on the table doesn't have greater than, it only has less than, right? So I have to do the complement. 1 minus the probability of Z less than or equal to 1.15, right? Let's draw it out so you can visually see what I'm talking about. Right? Remember that in the middle is 0 right here. So 1.15 is something like right here. So more specifically, I'm fancy, so I like to use colors, right? I'm talking about this area right here, right? And then what do I want to do? I want to do one. For one, I mean the whole distribution. Hold on, let me draw it out. See, I'm over here trying to be lazy. Y'all not catching me, but it's all right. It's all right. It's all right. So the whole distribution, right? I want to take that and I want to subtract the 1.15 from that. That's less than. And then the answer that I'm left with is the answer that I'm looking for. All right. So let's get into it. Hold on. I got you. So 1 minus this, and the answer is going to be 0 point something. So this is 1.15, right? So looking at the table,
Going in the back where it says 1.5.
no, you're going to 1.1, right? And then go across the 5. Yeah. So at the top is the hundred place, and the sides is the tenth and the ones place, right? So look at where they intersect that. So what is it? 87 point what? Say it again? That's it. All right. Boom, boom. So 87.49.
87.49.
Mm-hmm. So let me catch up with y'all. 1 second.
So happy I get something.
So I got 87.49. Then you just got to subtract it. What do you get? Yeah, so when you subtract it, what do you get? So I got the 0.1251. Right? That's it. Hey, you want another portion? So it's mad messed up. I don't know who put these on the desk. It ain't me. Just grabbing and doing them out. Here you go. You're welcome. All right, so that's it. Mhm.
0.09. So we will go to 0.0 and then go down to the 9.
0.0 and then to the 9. Yeah, that's it. Yeah.
So it's just always gonna be that way.
Always. And just so we're clear, the area I'm talking about is right here. And this is the 0.1251.
And I'm guessing that in the homework, you're just gonna have the pictures and ask us what it is, right?
No
Or ask us
pictures.
to match it?
Just a question like that.
Okay.
Like, so probability of Z greater than 1.15, and you just give me 0.1251. That's it. Yeah.
Okay, understand on equal to that. That's the only thing I'm.
Got you. Huh? Another one? Got you.
So if it's to the left, it's the same thing, but we.
If it's to the left, you just copy the answer. That's it. There's nothing else to do. It's only when it's to the right that we have a problem.
Okay,
Yeah.
but when it's to the left, it's simple.
So when it's to the left, you just copy the answer and that's it. Because the table gives you to the left already, so you don't have to worry about it.
Oh, so you just gotta, so for example, when you said find the error between Z equals 1 and 2 equals 2.70, all we did was go to 1.00 and 2.70, and that's it, right?
I subtract the two answers.
Ah. Not bad, not bad. Not bad at all.
All right, you try. You're welcome.
Yeah, he won't always.
I personally think sketching it makes it easy. That's just my opinion.
So the area is at -0.7, -1.79.
7.8, negative 1.78. Yeah. 78.
78.
Yeah.
So this is the area.
As long as you, because we mastered that already.
I didn't master it, that's what. But that's the area, I was 0.35.
Just look it up. 0.35, look it up. This is the area in between two.
That's why I believe.
Yeah. That's what we did yesterday. So try it out. Let's see. That's it.
Okay. Then I'll fix the, yeah, that's the range.
That's not right. Range is the biggest number, mine's the smallest number. That's it.
So it would be. Ten.
Mhm.
That's not the range from 10. It's the last one. New CV is right here.
That's not right.
But like I said, for like
That's way too big. It's like a single digit.
Is that the answer?
I guess so. I
I
trust
probably
it.
did them.
Probably. I didn't do it yet, but I trust it.
So I guess I just need to just flip them. I just need to just flip them.
The bigger number should be on top.
Yeah, so.
Oh, no, the smaller number is on top, excuse me, the bigger number on the bottom. But wait, hold on.
Yeah. Because S would be this number, but then divided by
I don't think this is right, this S.
the S
I think that's too big.
with the 2000
Yeah, I think it should be something smaller.
small.
Not in the hundreds. It should be like a single digit or something. Remember that what was that?
Yeah, right. Like S, it would be like 2.2.
It could be.
So right, because wait,
Remember what it is, right? It's the spread of the data, right? So look at these numbers, like all of them, just in general. Look at them, right? Is there any number that's like all the way over here, like or they all around the same
the kind of
area,
same area,
right? So that means that the standard deviation shouldn't be that big. It shouldn't be in 100 something,
Like the standard deviation, right? You add these all together, and then you get that.
and then you divide it by n minus 1.
Yeah, that'll be 14.
Minus 1, which is 13. So this divided by this, and then you square root the
Yeah,
answer.
square root, and it will be coming to this thing.
So then that's what's supposed to be there.
The CV.
Oh no, the standard deviation. Mhm.
What up?
That's all right. Take time. You're good.
Backwards.
You did?
Yeah, that's what I was trying to ask you.
I think you did it right because the answer is supposed to be positive. Should never be negative.
But here's the thing.
Yeah,
Isn't this less than this?
it is.
So then when I subtract it, I can't do it like this. I gotta do it opposite, no?
This is supposed to be here and that's supposed to be there.
Exactly,
Yeah.
so then the answer should
But the
be
one that,
this.
oh, reverse.
No,
Reverse, this goes first, then this.
is that not what I just did? Hold on.
63 cents is more than 3 pennies.
Take away 1, 0, 3, 7.
That's it.
So it's, yeah, so I'm doing it right, but I didn't know which one was the least number, so I did it backwards.
You had it right the first time.
You sure? So, just for reference, Professor, this is less than this. All right.
Owing the dollar is better than having 35 cents. You know,
Okay.
it's worse than that. Yeah.
Yeah, I was practicing.
This is the old one that you said I got wrong, because I had to like redo everything. So it would be this number, this is the new.
So
This would be
then,
standard deviation, that would be.
and I'm saying that's too big. Can't be that.
So I'm just gonna have, yeah, so I'm gonna have to
Try it again. You got
do all these
time.
again.
Try it again. You got time. Not
Well,
all
for
of
the
it,
two-
just the standard deviation.
No, I'm gonna have to just add all these again, so I get
Yeah.
my new number.
Got you. All right.
Professor, so I was supposed to do 1.67.25 divided by 13.6.
The
No,
reverse.
okay, so 13.6 divided by 167.285 equals times 100 equals, so it's 8.129. How is it not that?
It's too big. It's smaller than that.
Then what did I do wrong?
Use all the numbers. That might make a difference.
Okay. Don't kill me, I'm gonna stay right here.
So guys, while you guys are figuring this out, little commercial break, right? So long story short, I heard that CPH is gonna be shut down on Friday and Saturday. So CPH is where they have tutoring, right? So long story short, this weekend tutoring is gonna be online. All right, it won't be in person, just to let y'all know that. All right.
So it's still getting the same shit, and I put the whole number.
I don't know. The whole 13 point, all of that, divided by the 167 point, all of that,
I swear. But everything,
I don't know. I'll take a look at it in a little bit.
that's why I thought it was 8.
I got you. After class, I'll take a look at it. It
But this
could
is from yesterday.
0.37,
Yeah, 0.37, because it's a
not
negative.
0.037.
Zero, 0.0?
Look back at it. Okay.
Because it's a negative, I went to the negative side.
That's right. That's what you're supposed to do. Yeah. Yeah. Uh-huh. So everybody got it? All right, let's go through it. So, do I have my pen? Okay, I'm good. I got the wrong color. Hold on, let me get my color. So look, I want the probability of negative 1.78 less than or equal to z less than or equal to 0.35, right? So remember, our table only gives us probabilities that are less than, right? So I have to convert this. So I'm gonna do the probability of z less than the bigger number, which is the one that's on the right. So that's the 0.35. Because I'd rather have 35 cents than owe $1.78, right? So minus the probability of z less than the negative 1.78. All right. Let me just draw this out so that you could visually see what I'm talking about. So remember in the middle is 0, right? So what I'm telling you is that 0.35 is somewhere like here, and negative 1.78 is somewhere like here, right? Negative 1.78. And what I'm looking for, right, I want that area in between. So right here. That's what I want, right? But you know my table can't give me that, right? It only gives me less than. So what am I gonna do? I'm gonna take the probability over here, but it's 0.35, which is all of this. Hold on. Let me get the other color. Just bear with me 1 second. So I'm gonna take all of that and I'm gonna subtract. I'm gonna subtract the other area, right? So that's gonna be like somewhere over here. That's the negative 1.78. And then I want this area right here. Yeah. All right. So then after that, just look it up in the table. Boom, boom, subtract them, and that's it. All right. Is that what it is? All right. Let me see. So I'm going to switch over to the table. That's the wrong one. So yeah, that's fine. Yeah, that's fine. That's fine. So here goes 0.3. And you're gonna come across to where the 5 is, right? So then here's what I got. I got 63, 68, right? So let's write that in. 63, 68. So I got 0.6368 minus. Now I'm gonna look up the negative 1.78. Now be careful, that's the other side of the table, right? So I'm going to the other table where the negative numbers are. I'm going up to where negative 1.7 is, and go to the is 1.73? 8? What is it?
think it's 8.
Let me see.
7, 8. 1.7 and then go.
8. Yeah, yeah, it's 8. So to the 8, right? So that's the 0.0375. So that's
Yeah.
that's on the negative side. Yeah. So I'm on I got 0.0375 like that, right? And then little subtraction, bop, 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 and that's it, right? Yeah.
Use your nice little calculator.
Mhm.
It's 593. That's right.
5993. That's it. So 0.5993. So we good? All right. All right. All right. Good, good, good.
Just get ready to take this.
What do you mean?
Technically, we don't have to know.
The process, yeah. Mhm. Go ahead. No. Yeah. Yeah. Even if you on the test, right? Like say you on the test, right? And you forget it, right? For greater than, for example. It's telling you right here in the picture that the table entries for Z is the area to the left of Z. It tells you that. So you know that you have to do the complement to get the other side, right? But you don't even remember what complement is. Complement is right here, all the way in chapter 5. This what I mean, that like the answer for every question is already on the formula sheet. So y'all don't have to rewrite it, you know?
I have something that can help me with this, with chapter
Yeah.
7. So chapter
Yeah.
5 coincides with chapter 7.
Mhm.
So that's the formula.
Yeah. Everything is there already. Huh?
That's the formula we're using, right?
For greater than, yes. Yeah.
What exactly from chapter 5 can we use? So I can write it on.
Just the first one, the complement.
Okay, just that, that's it. So, all right, I'm gonna write that on my formula sheet.
So we good?
Yes.
All right, let's keep it going. Some good stuff here. So the next part of your homework is going to be finding the area under any normal curve, right? So in this situation, right, you were given the z, but what happens when you're not given z, right? Mm-hmm. So this is it. No, but this is the same thing, I promise. I promise you, this is the same thing. It's the same thing. So look, areas under any normal curve, right? Normal distribution areas. In many applied situations, the original normal curve is not the standard normal curve. Generally, there will not be a table of areas available for the original normal curve. This does not mean that we cannot find a probability that a measurement X will fall into an interval from A to B. What we must do is convert the original measurements X, A, and B to Z values, which we know how to do already, right? So here's a procedure, how to work with normal distributions. To find areas and probabilities for a random variable X that follows a normal distribution with mean mu and standard deviation sigma, convert the X values to Z values using the Z formula. So Z equals X minus mu over sigma, Z formula.
You put any area,
Sure.
how to
Right.
find the area of B, right?
Then use the table 3-2 of the appendix to find the corresponding area and probabilities. Simple, all right? Yeah. Good luck at the thing. Yeah. Ask them about scholarships. No, not scholarships. Financial aid, because I heard some stories that they're gonna have some trouble with financial aid. So ask them that. Yeah, yeah. For over here, you don't need it when you go to Lehman. You know, you'll be a nurse by then. Yeah. Mhm.
What does those two signals mean again, please? Signs?
Which single? Oh, mean is mu and standard deviation is sigma. Mean.
B?
Yeah, pop. Yeah. And standard deviation is sigma.
What's the bar?
Sigma, standard deviation. Mm-hmm.
No, it's just,
Uh,
we so keep rewriting it until it's fine.
I got you.
So,
So let me show y'all something.
I'm gonna write that in my comment this last.
So here goes an example. All right. So let's say we're looking for a normal distribution probability, right? Let X have a normal distribution with mean mu is equal to 10, sigma standard deviation is equal to 2. Find a probability that an X value selected at random from this distribution is between 11 and 14. So in symbols, we want to find the probability of 11 less than or equal to X less than or equal to 14, right? It's the same thing, right? So let's start by drawing a distribution just so y'all can see that it's the same thing, right? So look at this. You see, I forgot my pen. I always forget my pen. Right?
Be right here with you.
I got you. So let's say I have a distribution like so, right? I'm working on the drawings. I'm trying, right? So you know that your mean is always in the middle, right? But in this question, what's my mean? My mean was 10, right? And my standard deviation is 2, right? So let's draw it out. So if this is 10 and I go one standard deviation over to the right, what number am I going to write after 10? Not 9. No. So the standard deviation is 2, right? And I go one standard deviation over 12, right? Right. So if I go one more standard deviation over to the right, what am I gonna write? 14. And if I go one more, what am I gonna write? All right. If I go to the left one, what am I gonna write? 8. Good. If I go one more to the left, what am I gonna write? 6. There's no 6 here. I mean, excuse me. There's no 0 here because it's a different kind of distribution. It's an X distribution. If I go one more, what do I get? 4. Right. So now let's look at the question. Right. I'm sorry. One second. So the question is asking me to find the probability of 11 less than equal to X less than equal to 14, right? So what am I looking for? I'm looking for 11, which is right here in the middle, up to 14, which is right here.
11 up to
And what do I want? I want the area that's right here, right? It's the same question, right? But here's the thing, I don't know what a 10 distribution is. I know what a normal distribution is, where my mean is 0, my standard deviation is 1. Convert it into what you know. That's all you have to do, right? So if I was converting this, right?
So we will go to 10 on the table?
Nah, there is no 10 on the table. That's what I'm trying to tell you, right? So what you're gonna do is you're gonna convert it. So look, they want to know what's the probability of 11 less than or equal to X less than or equal to 14, right? You already know what's going to happen with this, right? That's just going to be what? The probability of X less than or equal to 14 minus the probability of X less than or equal to 11, right? We already knew that. We knew that was going to happen, right? But what I'm trying to say now is you can actually convert the X into a Z. So that's my next step, right?
That's Susie.
Mm-hmm. Yeah, I write it for you. Convert X to Z, right? So this is going to become probability of X minus mu over sigma less than or equal to Z less than or equal to X minus mu over sigma, which is going to become what? The probability of Z less than or equal to X minus mu over sigma minus the probability of Z less than or equal to X minus mu over sigma. Don't overthink it. Just plug in the numbers, right?
Are you?
So, yeah. So look, it's gonna be what? The first X is what? What do y'all think the first X is?
I'm sorry, what?
Hmm? 11. How you knew it was 11? Exactly, right? Minus the mean. What's my mean again? 10. Good. Over my standard deviation, which was what again? 2. That's it. Less than Z, less than, what's the second number? Don't overthink it. No, the other one.
You didn't go
14, right? Minus the 10 over the standard deviation 2, right? Is equal to probability of Z less than, just write them in, 14 minus 10 over 2 minus probability of Z less than, this one is the 11 minus 10 over 2.
So,
I'm just flexing. I'm just flexing. So this is gonna be what? Probability of, I don't know, what's this? 0.5? I don't know.
this is terrible.
What's the second one? I don't know, 2.0?
Professor, we gotta solve these 4 different equations in order to find this answer.
Just a what? What you missing? I got y'all.
I'm so confused.
I got y'all.
Oh, Professor,
All right, where did I lose y'all?
you lost us after the table.
The graph or the table?
The graph, you lost us after the graph. What is this?
So this is called an X distribution, right?
Yeah, this is okay. Everything else is like, what the fuck are we
So
doing?
good. So the next thing we gotta do is convert X to Z. That's it. Right? So y'all know my formula, right? I like to plug in the formula first, plug in the numbers into the formula, then I write my answer. So formula, plug in the numbers is my answer. That's it. Don't believe her. There's free food in Low Hall on 415. Oh yeah, that's right. The food is downstairs.
Yeah, that is a hot mess. That's why I didn't get food.
The food is downstairs in the pantry.
That's what they said, I made an appointment.
Okay. That's to tell you how much they give you that they can't even do it in a small little area over there, you know.
He said, bring your.
Shopping cart, bring your car. Like, yo, you don't have a car, you better Uber, you better Lyft. You know? Matter of fact, also like little commercial break. If y'all look inside the videos, there's a discount code for Lyft, if in case y'all want to take Lyft. So, in the video, you ain't never, you don't read the description of the videos. Oh.
So we just spent all our money on the baby. We still have, it's real.
That's right.
We don't got no cab, we don't got nothing. This is
So
just
how we
for
gonna,
lunch.
so how we gonna get the free food?
I'm not getting it. We're not gonna lose our parking spot. We're not gonna lose our parking spot and then have to pay parking. We just spent so much money on those medical bills.
What about them little things that you attach to the bike so you can carry? Yeah, they have those still. Yeah. Nah, because the pantry is next level right now. Like it's crazy right now.
I can't afford to take that home.
You can go tomorrow.
You could still find,
Yeah.
but that's not even gonna be crazy. Sign up right now, no, they
Yeah.
get time slots, I think.
I'm not an appointment today, but how the fuck I'm taking that home? I'm not going.
I mean tomorrow.
No, it's an appointment only. They're not accepting walk-ins.
They'll take
They
it.
didn't say that, they just.
No, when you go, they're gonna tell you don't have an appointment, bye. They're not giving you
They said
anything.
that in the email too, they not.
Yeah.
I just signed up and they said, call me.
Yeah.
All right.
Tell me what.
We're gonna see what happens tomorrow when I walk in at 6 o'clock. Like, what's up? What's up, yo?
Yeah.
Who is y'all favorite person over there? Y'all had a favorite person. Susan, who's your favorite person in the pantry again? I forgot.
She's so sweet, man. She's on the older side.
Yeah.
I really like her. I probably love her name. She's so fucking sweet, bro.
Yeah.
I don't know about
Yeah, that's great.
That's great.
All right, so look. After you finish at this, you already know what we're doing. Just gonna look it up and that's it. Right? So I'm looking up 2.0. Right? Let me see what 2.0 is.
2.0 and what?
It's 2.00.
2.0. Cause it's two.
2.00, yeah. Is it 1.5? I don't even know.
Wait, oh, sorry.
You might be right. I don't know. You might be right.
Is it 9772?
Yeah. 9 and then what?
9772, right? So then now I'm gonna write that down. Let me catch up with y'all. So I heard 9772. Yeah. No, not that, not that. The same one we were doing before. Yeah. Yeah, that's like in December we're gonna do that other one. Right? And then now I gotta look up 0.50. Hmm?
So that will be up top, 0.05.
You're probably right. Let me
So
check.
6950.
Six,
0.69.
6915. Yep.
Go to the,
Top part?
Yes, sir.
Mhm.
0.5 and go to zero.
Yeah.
I'm still confused, but I'm
Yeah.
like,
Yeah, I got it, thank you.
You got it? All right.
I'm still confused, but I'm.
Get your mind out the gutter.
Professor, so where did you get the 5 from?
The
The 2 is the.
from the formula, 11 minus 10 over 2. That's 5. Yeah. Yeah.
This whole here, listen, I'm crossing this whole formula out because I don't really know what you did and this is just confusing me.
All I did was I converted the X's to Z's, and then we were and did the same thing we were doing before.
That's how you got that?
Because 11 minus 10 is like 1, right? And then 1 divided by 2 is like 0.5. So yeah. Yeah. It probably is.
Professor, can you, okay, all right, can you rewrite this without everything except the formula? Just so I,
Mhm.
please, because I'm
You're allowed to just write the formula, but I wanted to show you where it's coming from.
not following this because that's too much.
Like if you wanted, if you wanted, right, you could go, you can go from this line right here to like this line if you know how to do it. Yeah.
Right, for the formula. Second one is him plugging in the numbers that the problem gives us.
Right.
And then the third one is all-
It's the answer.
Okay, let me just write the formula. Let me just write the formula.
Okay.
Where is it?
See where it is.
Up here, the first line. The letters.
Just the left and the right, that's it?
Yeah, that's it.
Okay, let me just write that
Yeah.
down.
And then the next line is the numbers, and the next line is the answers to it. Go ahead. Huh?
Why you said that it-
I did it twice. Weird.
Like that whole way?
Yeah.
You sure?
Oh, you mean like why? Mm.
Yeah.
That's what's confusing
I
me.
guess to simplify it, right?
To show you how it's being done. If it was me, I wouldn't do it like that.
Is that the only?
Yeah.
Okay, so I just wanna write the formula.
Yeah.
That greater than less, it turns into just greater.
Oh, my fault.
So basically.
Good
if I
catch.
write the formula, I might be okay, but if I write all that down, I'm gonna just do everything.
My fault. Good catch. My fault. My fault. My fault. Now you know what it was? I got lazy and I just started just, you know. Yeah. Yeah. That's my fault. That's my fault. Yeah. But this is good though, right?
As long as it's a bar time. You got a bar time? Bro, I need this shit out of my system or I'm gonna do this wrong.
Put the picture on top.
No, stay full big on top.
Or circle it and put, this is not, like, yes, this is not.
No, it's too late, don't worry about it, it's okay.
Are we gonna
put
do
a
another
little
problem like this?
Sure.
Professor, I was all right with the formula, it's just when you simplified it, I was like, what?
But it was easy though, right?
The way you simplify it is confusing for a person that's just learning it.
I got you.
But if I knew it, I'd be like, hell yeah, professor, yes.
I got
But
you.
because I'm just learning it, it's too much.
Got you.
Remember, professor, you're a genius. I'm not a
Thank you.
genius.
Appreciate it.
I'm not a genius, professor.
So here's a little interpretation, right? So the probability is 0.2857, right? That an X value selected at random from a normal distribution with mean 10 and standard deviation 2 lies between 11 and 14, right? That's the interpretation of it. All right.
just give us this one problem and expect us to like.
No, Professor, we're gonna have to do 3 or 4 more. Yeah, there's no way, bro, not after all that.
Hmm. All right, we can do that.
So, Professor, please
down
do at
for
least 3 more.
3, 2, 1 more. There's a whole lot.
I got y'all.
Exactly. That's why I want her to do it again.
So let's take it up a notch then.
No, don't take.
No, just do the same
Yeah.
problem.
It is the same type of problem. But look.
Yes, just do the same, no, Professor,
Now,
no.
now we got a story.
That's right.
Yeah.
Sir,
Yeah.
stand up, oh, come on, we can't go here,
Yes, we can.
no.
It's light. It's light work. It's light work, I promise. So check this out.
No. Professor, I can't. This, because I don't understand the one you just did, I can't.
You
It's not
can.
possible.
Try it out. Try it out. Look.
Professor, can we please just do one more before we go to this?
This is the same
please?
thing. It's
No,
one
that's
more.
not the same thing.
It is. Check it out. Look. Let me read it out, and you're gonna see it's the same thing, right? The lifespan of a rechargeable battery is the time before the battery must be replaced because it no longer holds a charge, right? One tablet computer model has a battery with a lifespan that is normally distributed with the mean of 2.3 years, right? So this is key right here, right? It has a mean of 2.3 years and a standard deviation, right, of 0.4 years, right? What is the probability that the battery will have to be replaced during the guaranteed period of 2 years? Right?
Let me write the key points first. The mean is
100%.
No.
mean is 2.3, the standard deviation is 0.4.
Mhm.
What's the probability that
Yeah,
that?
2 years it usually lasts, 2.3 years it usually lasts, so.
So what's the probability that it's going to last less than or equal to 2 years?
7.7.
Just do the math on it.
What's the?
Yeah.
That's what I do.
The 2?
It's,
The 2, you tell me, what is it?
That's the.
It's one of 3 things. So the old thing, that's sigma, that's your standard deviation. No. The one that says standard deviation is that.
Let me write this formula
Right.
again.
Wait, this. X is 2.
Good.
Okay.
All right. So we heard that. See, I always forget my. So X is 2. So what's your mean?
Hold on, wait, Professor, wait, I'm trying to.
What's that? Which one's the standard deviation?
Oh,
Well, no, what's the number? 0.1, no. 0.4. You said 0.1. Okay. That's true.
So why you going on different bit?
because we try to understand.
I just got mad excited and then I looked at the board and I okay. But that's the point, like, we.
But you know that's not the full answer. You know that's a piece of it. That's a piece of it. That ain't the full thing.
wait, so let me write that down, hold on a minute.
For
So
the
you
question?
took Z equals X, take away U equal, okay, so it's.
If you want to. I want
So
the
it's
probability.
Over 0.4 equals negative 0.75. That's what I'm doing.
So look, I want the probability of X less than or equal to 2. Right? So what are you gonna do? Plug in the formula. This is gonna be the probability of Z. Nope. X minus mu over sigma. All right, do it.
This now, because I thought we already.
This is-
did the answer.
Nah, I'm showing the work now. This is the way I want it. Yeah.
So what else you want us to do to get the whole thing?
plug in the numbers.
So then the number.
The
I
same
thought we
thing.
did
That's-
that.
We didn't finish it yet.
0.4.
Yeah.
With that P.
Professor, is it take away 2.3 over 0.4, plugging them in?
P, right.
And then what are you gonna do with that number?
0.75.
What are you gonna do with it?
So now you want us to, oh, Lord. Can you walk me through it?
It's the same thing.
But why did you put P equals X is greater or whatever to 2 and?
Because that's what the question was asking.
So now you want us to look for 0.02 and then.
What am I looking for?
Was.
Okay.
I'm trying. I'm sorry.
So tell me what to write on the next line then.
I don't.
This is gonna be the probability of Z less than or equal to what? What's X?
It's 2.
Minus, what's the mean?
And
2.3 over 0.4. Okay, so this becomes probability of Z less than or equal to, what's the answer?
I'm sorry, what you said, Professor?
It's negative, right? 0.75.
Yes.
And then what do you do after this?
Are you supposed to look this up on the table now?
Good, do it.
Negative 0.75.
Like this?
Negative 0.75.
So first look up negative. Where's the negatives?
Here.
Mhm.
Negative 0.7.
Oh, we go to 0.7, right?
So that's 22.2296, is it that?
2296 or 66?
Oh, 66, my bad, guys, I wear
2266.
glasses. So. Equals 0.2266, and that's the answer?
Yeah.
That's all you wanted?
That's it.
So you want us to break our heads,
Mhm.
raise our blood pressure, get tachycardia, go into like panic for fucking, that's all we had to do?
Mhm.
Professor, why is math so complicated? This is why everyone hates math.
Wait, how did you get that?
It's so
The
simple.
table. The table.
The table.
Why you want to do it on the calculator? You can. There's a way to do it on a calculator.
But that's crazy,
No, I'm
Professor.
dividing
Mhm.
the third.
Oh.
one. I'm dividing, okay, that gives you this answer. And then you go to the table now, right? But what do you put equal?
Oh, that's what, because it equals that. Yeah.
Cause when you look,
Go to 0,
Exactly.
7, and then go up. 7, 7, 3, 4. But why, it's a 0.7734.
no. What should it, let me see what you did.
I'm gonna do my good. 0.75, and then we go up 5.
Are you on the negative side or you on the positive? No, go on the negative table.
Oh, that's the negative.
Now do it, and now. No, but you're on the right track, it's. Listen, it's confusing out here.
Oh, something you.
I got you.
Think what
It's
down.
I mean,
It's confusing.
Okay.
it could be done. It could be done on the calculator too. We'll talk about that next time. No problem. Go ahead. We'll catch up.
Hey, I gotta go get.
Remember, get the. Yeah, you got time. You got time. Yeah, you got time. Yeah.
Yeah, I gotta go home, Professor, I don't even know.
Yeah. Mhm.
No, I'm supposed to know how to do that. See, I don't know.
The question told us to do it.
My phone.
See, because I could take
Yeah.
it.
Yeah, so. That's why we have school.
You could do it on YouTube also. Just pause it and then cut it. Yeah.
A lot.
I got you. Yeah.
I was maybe. Sorry. That was my son, like I had, like, since he was born. I got a son. I already know. Oh, bless. Is he really? He's really good, really. Don't carry from all the things. All one is all furniture, all furniture, don't never go up and down the steps, and don't let folks make them their time. I mean, that's what we want. That's why my daughter. Thank you, she loved those days. She loved, so thank you, I love you. Something like that. It's called ICBD. The disease, just look it up and make sure you put something on it, right? Fine, but I'm willing. Thank you so much for that. You're welcome, God bless.
I'm like trying to think right now.
You know, you can let us go. It's not for our brain. That's the very thing with this.
All right,
Professor, don't tell me
let's
teaching us something new
yeah,
when I'm
yeah,
walking out.
yeah.
Professor.
But it'll be good though. It'll be good though. So let's say I wanna check this answer, right? I want to see that it's actually right. Now, look, let's say I want to check this, right? Can check it in the calculator. So
Sorry, Professor, how can you be a negative 9 feet?
it's all good.
Why I thought that gave us a butt and back that we. I'm sorry. Hey, I used to love being like. Listen, I used to like smoke.
You know that they're making new episodes now
Really?
on
But
Comedy Central.
Wait anymore, so it's not gonna hit the same. It's not. You know what? I think it's not gonna hit the same. Bye, guys, you all have a stay. And listen, y'all really should go to the pantry. If I had the right means of transportation, I would have went. Y'all should go.
Y'all should. Word. So look, let's say I wanted to draw this distribution real quick, right? I'm gonna show y'all how to do it in the calculator. Yeah, I know that right here is 0. This is negative 0.75, so that's going to be over here, right? Negative 0.75. And the area that I want is the area to the left, right? So I want this area right here, right? So what I want you to do, I want you to pretend that you're standing right here in the distribution,
See, that's my brain.
right?
You're worried about.
I got you. I got you. Yeah, kind of. So over here to the left, this is what's called negative infinity, right? Your calculator understands negative infinity as negative 1e 99, right? So if you were going to do this in the calculator, let's say I want to verify this answer right here, right? What you have to do is you have to go to normal CDF, right? Now, you guys have the 36X Pro, right? So you're going to press second stat regression, right? It's okay. I'm just gonna tell you. You press second, then you go to where it says stat regression / distribution. It's the data button right above the data button in blue, right? So after that, you want to go across to where it says distribution, DISTR, right? And then when you go to distribution, you want to go down to where it says normal CDF, right? So when you go to normal CDF, they're going to ask you a few things. I think they're going to ask you about your mean. They're going to ask you about your standard deviation. It's going to ask you about a lower bound, and it's going to ask you about an upper bound, right? So now you already know what your mean is, right? For a normal distribution, your mean is always 0. For a normal distribution, your standard deviation is always 1. Your lower bounds. Now look where you're standing, right? Right? You're standing in the distribution. What's to your left? That's the negative infinity, right? So that's going to be the -1 E99. What's to your right, the upper bound? That's the -0.75. You just type it in and then boom, right? So let me show you how I'm gonna do this. Oh, by the way, there's a button on your calculator that's called EE. It's in blue, EE, right? I have it right here above the number 7 on mine, but you guys have it on the 36X Pro. I don't remember where it is, but it's there. I'm sorry? Sigma is a standard deviation, right? So I'm gonna do it on my calculator real quick, right? So I go to distribution, I go down to where it says normal CDF. Now, my calculator and your calculator has it flipped. They asked me about the lower bound and the upper bound first, and then they asked me about the mean and standard deviation. But we should be entering the same kind of thing, right? So -1 E99. My upper bound is going to be -0.75. My mean is 0. My standard deviation is 1. I'm going to paste that together. Boom. Oh, what happened here? Hold on. Oh, let me tell you what happened here. So come back up here, right? So be careful that you place negative and not minus, right? I hit -0.75. This is negative right here. This one. You too. So when I click enter, I get the same answer. That's how you do it in the calculator. Now, let's say hypothetically speaking, right? Because I know time is going, right? Let's say hypothetically speaking that, hold on one second. I'm just gonna switch back to the drawing. It should have. It should have gave you the right answer. But I'll show you it afterwards, right? Now, hypothetically speaking, let's say that the distribution was like this, right? And I was looking for something in between two numbers, right? Let's say that this was 2 and this was like -0.7, right? And I'm standing right here in the middle, right? So for this situation, if I'm doing it in the calculator, right? Normal CDF, right? My mean is still 0. My standard deviation is still 1, but my lower bound, what's to my left, that's the -0.7. And the upper bound, that's the 2.
Yeah.
Enter, boom, right? Let's say that it was greater than. Let's talk about that. Let's say I have a distribution like so. Let's say that this was 2 just to make life easy, and I wanted it to be greater than, right? So for normal CDF, right? My mean is still 0. My standard deviation is still 1, right? But remember, I'm standing here now, right? That's where I'm at, right? So my upper bound, right, is going to be infinity, right? If remember, infinity is what? It's the 1E99, right? So lower bounds will be the 2, upper bounds will be the 1E99.
Yeah.
Enter, and then that'll be the answer for that. All right.
Take a picture.
This is an
So
example.
when I go, I use my calculator.
Yeah. So if you want to do it on the calculator, this is how. Lower bound is whatever is to your left. Upper bound is whatever is to your right. How you doing? Huh? I haven't yet. Next week I'm gonna give it back to you. Yeah, and then same thing, you can go to tutoring, like again, I'll give you half the points back. You give it back to me.
Yeah.
Yeah. You're welcome. It's not 0. Yeah.
The upper bound would be -0.75.
For which one? For this first example here?
There would be, they want this one,
Mhm.
and the upper bound will be the lower bound will be infinity, right?
For this example here, which one? No, but for which example? This one or that one?
Why did you just,
Yeah.
what did you miss?
Or are you talking about this one, the top one? Which one?
There's two different ones.
There's three different ones. Yeah. Uh-huh.
On the upper bound,
Uh-huh.
you gave us that number, but when we have the upper bound, what do we put for the upper bound for the different?
Whatever's to the right. So imagine that you stand in a distribution each time. Whatever's to your right is your upper bound, whatever's to your left is your lower bound.
So, on the chart,
Mhm.
so if the standard deviation is. This equation. It's saying,
All right. Every time you have a distribution, imagine you're always standing in the middle of it, right? Whatever's to your left is your lower bound, and whatever's to your right is your upper bound.
the. The middle number, and then 12 would be the.
Oh, if you're doing the original question? Yeah, so your lower bound would be 11 in the original question, right? Your lower bound would be 11, your upper bound would be 14.
Yeah. You didn't do
Yeah.
10 and 11.
We didn't need 10. 10 was the mean.
Yeah, but
Right.
so whatever's to the left of it.
Yeah.
So we would
Yeah.
put
Bye,
12.
I see you. You don't need 12. No.
So
That was just to draw the distribution for you. Yeah, that's all that was. Yeah.
Okay,
For a normal distribution, you count by ones. But for the X distribution, you count by whatever the standard deviation is.
so whatever's to the left is. Is the upper bound or the lower bound from to the left?
To the left is the lower bound, and then to the right is the upper bound for the calculator. All right, can I close this?
Yeah.
Yep. All right. I'm gonna stop the recording. Everyone have a good night.